special attention. You can say that, an offshore oil rig has a lot of subsea components, but you only have go up maybe 100 meters into the air, whereas for offshore wind, you're talking about, 30, 50, 100, very flexible 150-meter towers that are all spatially located maybe across a much larger area. And so the accessibility needs for boats, the orientation of your boat platforms, they're all things that then have to be considered based on the correct assessment of not only just the weather, but also the climate. And these are two really important concepts that we can only know, but what we can know about the site, when we're developing the characteristics of a site, we are looking backwards, and then we're trying to make projections into the future, but it's really based on what we call a hindcast. And so what can we say about tomorrow? What can we say in a month from now? And what can we say generally over 30 years? These are very different characteristics that we use in different fidelities over the course of the project. So when we think about how this develops too, not all data is the same for all projects phases. So at the very early stage, this is an American language here, but it is international, in the scope. You're deciding at a company whether you want to actually bid, whether you think a project area is going to be good enough. At this stage, you already need to know something about the site, but you don't necessarily have the money, you don't have the in-depth measurements, you don't have really the design grade models at this stage to determine what the cost of energy is going to be, what the risk factor is going to be. And so at this early stage, even perhaps before the project is a project that the company owns, you do have to have mid-ocean and wind resource engagement and assessment. This includes risks and opportunities that you can identify based on the unique characteristics. Really, no two parts of the world are the same, and they all bring their unique combinations of atmospheric and oceanic conditions. And at this stage, knowing this unique site, you start to develop your measurement strategy. And in your measurement campaigns, maybe you need to have the same type of LiDAR measurements. For example, you're always going to have a 40-meter and 150-meter level measurement. But the other characteristics you're also measuring really depend on your assessment. And this assessment comes from open, publicly available models, maybe models you have from previous projects, or other kind of knowledge, maybe working with industry and other partners in academia. But at this stage, knowing these unique features is already important to understand what's going to be unique for each package. For example, what are the substations thinking about their unique challenges are going to be in this area? What what is this, the ground soil type like? Is this going to be a particularly mobile sands area? And at this stage, you can already start preparing and trying to understand what sort of measurements and models you're going to have to put together. So then you're successful. You've won the project, and you're ready to put out your measurements. And this is actually a very long process. So you, at minimum, need 1 year of measurements. Better in some cases, different philosophies. You can have a lot of measurements over 1 year, or you can have fewer measurements, but over a 2-year period. That would be for, say, capturing interannual variability, et cetera, and spatial variability if you have a lot of different measurements throughout the site. I say it's going to take a long time because you also have contracting and procurement to go through. These are very, very big, costly packages, putting out a LiDAR buoy, et cetera. And so it takes some time. That has to be built into the project as well, because you can't really say anything. You don't really know the ground truth. You have some public models, maybe you have a governmental buoy that could be nearby, but it's not going to be the specifications that your project needs. And it's difficult and ambitious to move beyond in terms of technical detail of the project without a full year of measurements, because these measurements will then be used for your in-depth modeling. And in the course we go into a lot more detail about what these measurements are, how they're carried out, what they contain, kind of what errors we can expect from these different instruments. Every measurement brings its own opportunities and challenges, and then also how they're used in the models themselves, how they help us understand what might be true in a larger, more encompassing design grade model. And so at this stage, it takes, we're really talking about from, when we win the project through the modeling, through the measurements up through the modeling, it's at least a 2 to 3 year process, just to kind of kick that off the ground. So you can imagine this is a very exciting time because, designs need to get started, things need to start happening. And at the same time, we're limited and we have to get quite creative with what we can say and what we can't say, given the data quality available to us. At the same time, we do have wind resource that is working on its side of the early stage development. It's coming up with project build-outs, assessing the most appropriate wake models for this project, for this region. Atmospheric stability is really important here for this sort of thing. The variability of wind and wind directions, proximity to the coastline. These are all going to affect a layout in a very early stage. And that all fills into a yield assessment. Again, you're selecting the most appropriate wake models. Different wake models for different places can perform differently. And then you're collecting your losses also from the different packages, even at this early stage, electrical losses down, if your operations and maintenance team have numbers for downtime in this region that is expected or likely, all these sorts of things feed into how you calculate overall NCF and availability. So then you continue on, once you have those measurements and models taken care of, you can really start your detailed design. And again, we need the package input from all packages, even onshore substation. There is flooding. There's a cable connection to the export cable onshore to export, which is going to we have to care about the erosion that might happen at that coupling joint, due to storms or just daily life. And so again, checking in frequently with your Metocean and wind resource team to understand updates to the design and how that may or may not be affected by prevailing conditions. And it's really at this stage that you have your document certification. So things have to be pretty well known and pretty nailed down after that point. Once your site characteristics are certified, going back again is a bit of a process if there are any changes that are discovered, or if there are more details that need to be incorporated. So at this stage, it is really important that that communication has already happened with the packages and understanding the critical needs. And it's not necessarily expecting that everyone has an oceanographer or an atmospheric scientist on their team, but saying, hey, this is the size of my cable. This is maybe the maximum temperature this can work at. And at certain times of the year, that'll tell us when we should collect our seabed sample, for example, to get seabed temperatures, and that can help us help you size your cable. At this stage, we're also in the wind resource side. We have a full resource assessment that's also written, and a turbine supply agreement now at this stage is also happening. So then once the design is finished, Metocean doesn't go away, and it shouldn't go away, as I'm sure you're aware, right? Safety, and boat access for work, for installation, for any sort of activities that we need. They should have good access to forecast, access to understanding about how the site performs under certain conditions throughout the year. So we mentioned measurements, and we have to have at least 1 year because the site does vary, as you can imagine, between seasons. And what might be the worst season, say, in the North Sea is not necessarily the worst season on the East Coast of the United States. And understanding the types of boats that you can take out in certain conditions, the workability, the amount of time you have for certain operations based on the sensitivity of those operations, and basically your most optimal project schedule. These are all weather dependent. And there are some things that the weather happens, we have a ton of storms. It just is, bad luck after bad luck. Sometimes this happens, but often with good detailed Metocean data at the beginning, in the middle of the project, we really can optimize this schedule so that we can't just throw up our hands and say, oh, weather happens. Who can blame the weather? Who knows what's going to happen? So in the installation phase, the Metocean team is helping with forecasting. There should be observations also, excuse me, in the ocean at that time. A forecast should be calibrated to the local measurements that we have there. Maybe there are measurements around that it can be calibrated to, but also within your site itself, and that'll make a big difference especially if there is a big storm or if there's a nearby passing storm and there's a disagreement about whether work can be performed, whether it's safe to go out to, turbine A versus turbine B. This is a really critical input that your Metocean team can have in helping to assess, well, first of all, model strengths and weaknesses of the forecast itself. Can it really capture waves coming at this angle of this nature at this time frame? And is it really going to is it really going to influence that turbine over there, or is there some maybe some blip in the forecast, some faulty measurement that we have? Excuse me. And finally, with something interesting in the United States, these HF radar is used extensively in the United States, and these systems exist elsewhere as well. But they really impact wind. Wind really impacts them in the United States, and so there's a lot of work to be done. The rotation of turbine blades actually interferes with the measurement, and so current sensors or current measurements are completely noisy around these wind farm areas, and so this is something that we also have to account for in the United States and anywhere else where there is a density of measurement of surface current by HF radar. And also during installation, on the wind resource side, we have our power performance test. And this is to ensure that what the developer of the turbine has said is going to happen in these conditions, what is under warranty, is actually happening over that period, and to work out and make sure what has been agreed upon is actually happening in terms of power production. And finally, we have operation, and I'm realizing now I missed decommissioning, and maybe our friends in the United Kingdom and elsewhere in Europe can help refine that, what that looks like. But for operation, again, we have power performance testing, and then we also have an understanding of how well the models did in this region, because there's always something new to learn in terms of atmospheric science in these regions, in terms of oceanography in these regions. Where did the model succeed? Where did the model fail? How can we change our measurement procedures for the next project, our calibration and validation preferences for the next project that we do in the region? And then, of course, a really important thing that we should probably talk about more in the industry is supporting environmental monitoring. Of course, we have marine species that are of importance. We have stakeholder engagement with the various ocean users in the area, fisheries, et cetera. And there is room for collaboration and better enhancing our understanding of how all of the different stakeholders are interacting. I know that we had a measurement buoy out, and the fishermen really loved to have this measurement that was no measurements around, and they were really upset when we took out the measurements themselves. And so that was a really easy way to stay engaged with our fishers and understand what they needed in the region, and to kind of help make the region a more resilient area. Okay, so that is really a brief overview of the Metocean and wind resource timeline. And now I'd like to jog you in the audience, your brain, about what Metocean parameters you think go into each of the major packages of an offshore project. Oh, so Sarah, actually, if you could take this down, and now we'll go to the Menti.
All right. So yes, sorry, for those of you who are just joining, I'm going to send you a QR code that you can scan with your smartphone, or a link that you can join from your laptop. There we go. And this is the platform that will enable you to now join the activity that Sarah has prepared, as well as to access soon after the anonymous question platform. So menti.com, and the code will be 775032838. Here we go. Great. Okay, so I will now pull up the Menti platform. Okay. Great. Okay. Give everyone a second to jump on. All right. Sarah.
Yeah. So the words are a little small here, but I'd love your perspective. How many Metocean parameters apply for which of these for offshore substations?
And you can select multiple options, by the way,
That's
here.
right. That's right. All right, then we have 4 out of 12.
Make sure you hit submit at the bottom, I believe it should say. Yeah, just tap as many as you think are relevant and then hit submit at the bottom. And it's totally anonymous, so don't worry about being incorrect.
Yeah, this is I don't expect all these parameters to register for everyone. All right, almost there.
Okay, Sarah, what do you think from the responses?
Yeah, yeah, indeed. So in fact, surprisingly, reference TI is important because your foundation is attached to your tower, is attached to your wind turbine. So at this stage, you will have to have kind of a fully consistent system that you're modeling. So ideally, your foundations are being modeled with your turbine supplier. So reference TI is important. Seabed temperature is not important. Actually, John, if you have any comments or if you want to chime in here too, you're more than welcome to. But seabed temperatures really not for the foundations themselves, maybe for other components. Wind-wave misalignment, of course, as it goes through, again, we have a combined analysis between the turbine itself and the foundation. Foundation, if you change your turbine, you have to change your tower. If you change your tower, you will have to change most likely your foundation design. And so your wind-wave misalignment will influence that. Reference wind speed, indeed. Scour protection type is part of it. Positive and negative surge, good. I'm glad that makes sense. Seabed depth, sorry, this was vague. I meant stable seabed burial. Your seabed is going to go down on GFED or geophysical and geotechnical studies. So yes, your turbine foundation will be going many meters into the seabed, but seabed depth, this is actually not a really critical parameter, and that's not measured by the Metocean department. That is measured by or assessed by the geotechnical department. So seabed, really stable seabed, would be important when we're talking about mobility and cables, perhaps. And then that's an interaction between the geophysical, geotechnical, and Metocean teams. And indeed, severe sea state and extreme water levels are two important things for foundations as well. Extreme water level, so this is when you talk about the summation of your tides, your high water level, your surge, and then your wave crest height on top of that. That is going to give you a different value than your stable seabed or your severe. We have extreme, severe, and normal sea states. All right, and let's see, there's one that I skipped here. Directional extremes. So directional extremes for foundations, they are calculated. They they are used. They may be more important for some packages than others. But yeah, these are calculated at this stage. All right, let's go on to the next one.
Okay, so same question, right? But just for foundations.
No, excuse me. I think the titles were flipped in this one. Did I just totally confuse everyone here? Can you go back for a second, Sarah?
Yeah, so the last one was substations.
Substations.
Was what it
All
said
right.
at the top, yeah.
Guys, I apologize. Did I mention I just got over the flu? So yeah, indeed. Wow. So just pretend all that was for foundations. Let's see. So indeed, reference TI is not important. reference wind speed is also not important for offshore substations, because we're only talking the top of the substation is going to be much shorter than your wind turbine itself. So you will have to have a wind speed, but reference wind speed is a very specific parameter calculated for turbines, and you're talking your 50-year extreme wind, which is very different than the average wind, say at 100 meters at the top of your tower or something like that. And indeed, directional extremes are much more important for offshore substations than for foundations. Positive and negative surge, certainly seabed depth. Again, I would say the same thing as I do for foundations. You are going to be drilling some amount into the seabed, but it's about seabed mobility, and it's really for cables where your stable seabed, the assessment of your stable seabed is going to be really important.
Seabed depth is important from a point of view of setting the deck elevation for a substation. So in this context, pretty key.
Yeah, indeed. So this is where extreme water level becomes really the key and the most important parameter that we're talking about from a mid-ocean perspective. If we're talking about the DNV guidelines, standards, we're talking about a 10,000-year crust height and how you calculate that. It's a really mathematically sensitive practice, and so that is really relies on the quality of your modeling up to that point. A small change in significant wave height, which is the top third, the waves in your period, the height of your waves in the period that you've measured and analyzed, a small change can result in many meters extrapolated difference between a crest height. And there are multiple ways to measure crest height. They are based on different actually internationally, based on 2 different measurement projects in the Gulf of Mexico during hurricane conditions, and they come up with different results, and one is more suited for certain regions than others. And so this is a very sensitive and very important parameter. Also, for deck height, because decks aren't designed for wave loading of that capacity. Of course, it's a human safety risk. You don't want waves to make it up where people have work surfaces. You also then on the other side have, if you have a very tall tower, you have boat accessibility as well. You want to make sure that you have a boat that has that actually has a height in order to be able to access the platform at that height as well. Let's see if there's anything else here. So all right, let's move on. So I've already kind of given you guys the answers for foundation. So let's see how much you were listening to what I was saying.
All right. Also, maybe Sarah, in the interest of time, because it's already 10:33,
right.
we skip ahead from foundations to the next one.
Okay. Let's do that. Yes. All right, for cables.
Yes. And so, to the attendees, probably now we'll go a little bit past 10 or 45 past the hour. So hopefully you can continue to join us. Okay, last response is in. Sometimes there's a bit of delay from hitting the submit to it appearing, but all right. How did they do?
Yeah, indeed. So scour protection is going to be important for cables. Seabed depth, again, we've been banging on about that this course, or this little webinar. Seabed temperatures is going to be a really important one for here. Landfall erosion, indeed. Extreme water level, I'm not sure. It's going to be varied one way or the other. So that's really not an important parameter. Slack tide also, that is more for an offshore substation for if we have to have divers. Slack tide, I guess, diver speed when you're laying the cable. Indeed, it could be important because it's a sensitive process. So indeed, a reference TI, reference turbulence intensity, not needed. Especially if you're, the way you're lowering cables is really just not even in the atmosphere boundary layer itself. Okay.
Black tide sometimes is important from a visibility point of view. In some regions, the only time you can see what you're looking at on the seabed, so laying cables might be relevant.
Thank you, John. That's great.
All right. So next one.
And this is the last one.
Okay. So by wind resource, you mean the Metocean parameters that then help you classify what the wind will look like?
This is what a wind resource analyst will use from a Metocean model, from Metocean measurements, to determine their calculations. What is a 50-year wind speed? What type of turbine should we select? So there's a class and a subclass in terms of turbine type, ABC, subclass based on turbulence intensity. These come directly from your Metocean measurements campaign.
Okay. Metocean has so much impact.
All right. So severe seas is a really interesting one because indeed you do have to have a tip clearance with the ocean surface, and this is for boats transiting. It's a parameter or a governmental requirement, I think. So indeed, understanding the severe sea state is important well, I guess I'm not going to be too picky here. Wind resource analysts, of course, are taking this into account when they're selecting your turbine, selecting the turbine height, the tower height itself to maintain that air gap. And of course, that is always going to influence the aerodynamics, although I don't believe our models really get to that level of refinement that we use in the industry. Extreme water level, probably not, unless because extreme water level is a very specific definition, but it's within that same concept. We want to make sure that there always is that air gap of whatever country waters you're operating. Wind wave misalignment, of course, is very important for your wind resource analyst. It's not directly taken into the wind resource assessment, but of course, you have to understand maybe above a certain angle of misalignment, your turbine isn't functioning, and that influences your generation, that influences your availability, and your overall net capacity. Directional extremes, of course, also very important for the tower design that is owned directly by the turbine package itself. And reference TI and reference wind speed are the two main parameters for wind resource. All right. So in the interest of time, the final discussion would be around permitting requirements. But why don't we move on and to the next part of the webinar?
Okay, great. You mean now John's part, right? Okay, great. Thank you so much, Sarah. And well done, everyone. So John, would you like me to share your slides as well?
Yeah, so you can. Yeah.
Right, sure. Let me pull them
Can you hear
up.
me okay?
Yes, loud and clear. All right, now I just need to find. Oops, did I close it? All right, just give me one moment to pull them back up. Maybe in the meantime, you can introduce yourself while I'm pulling that back up.
Sorry, yeah. Yeah, John Upton. I've recently left the corporate world, the safety and security of corporate bubble. Been working in Metocean for 30-something years for Fugro and Shell. Last 5 years in specifically in the offshore wind team in Shell. And I've now set up a consultancy. Pleased to be here and nice to see some familiar faces and some new ones. What I'll be doing is just talking through just a really high-level summary of what we will be presenting in a couple of weeks' time. And that's components of a Metocean campaign. My background is through measurements of Metocean parameters all over the world. So putting buoys in off boats and hanging things off rigs to measure the Metocean environment, and then see how that feeds into design and operations. So I'll do that briefly, and then we'll have a chat with Tony and Tom, who have been sitting patiently alongside us. So yeah, next slide, please, Sarah. Yeah, so what I wanted to do really is just talk through some of the key things about Metocean measurements and what do we do, why do we do it. Sarah's talked already about the need to measure. So fundamentally, we need a ground truth. We need to take 30 or 40 years of model data and extrapolate that out to 1,000 years or 10,000 years to give us our extremes. But we need to know how that fits the year that we're measuring, how we use that then to calibrate the year or two. We use that then to calibrate the hindcasts. So in most instances, we would say, yes, we absolutely have to measure. There might be some cases where, for instance, Southern North Sea, UK sector, Netherlands, Dutch sector, German sector even, and Denmark, we have very good view of what the wind resource is and what the Metocean conditions are. So we might actually temper our desire to carry out Metocean measurements. But really what I'm saying is fundamentally we do carry out measurements, but regionally we assess whether or not we need to be very complex, very comprehensive, or whether or not we can scale that back. And obviously we talk about safety all the time. Safety is our priority. This is a high risk activity. We're working on the back deck of spot vessels in different regions where language might be a barrier, where you've got people who are really keen to do the work but not necessarily experienced in doing that work. We've got very sensitive equipment. Some of it is quite large. We're talking about buoys up to the weight of 12 tons, but you're also using wires that are probably about the size of your thumb. So you've got huge loads going through small pieces of kit and sensitive equipment. This is going to go in the water for a year or more, and you need to know that when it's in the water, it's working and it's running properly. So there are lots of things that we need to manage on the back deck of a boat. But one of the fundamental things that we need to understand is that has to start right at the contracting stage. And Sarah was talking about that. That is quite a protracted period, and it is. We need to make sure that the right pieces are in place and the right competence and experience is in place from that point all the way through. The picture on the top right is a good example where something went wrong from a safety point of view. Basic things like sea fastening. These were ballast weights that were being used for some current meter moorings on the seabed. The vessel went out to do the work. Mediterranean, fairly flat, fairly calm, benign seas, but then the vessel turned to come into the mooring location and all of the weights slipped to one side of the vessel. So they had to limp home back to port like this. And that was down to poor planning, lack of experience. So basic fundamental stuff. Key factors that we need to consider. Sarah's already alluded to the fact it's quite a complex operation and expensive. We're talking multi-million-dollar campaigns on the whole. So we need to make sure that we're spending that money appropriately. And there are lots of things that we need to do when we're scoping and managing. We can't just say, right, here's a purchase order to this company in this part of the world. It has to be quite rigorous, structured, formal process to go through. And you might be surprised that sort of process involves probably at least a dozen different groups and individuals. So it's not just the Metocean engineer talking to the contractor and saying to management, I need that amount of money. It's so many different factors like marine assurance, obviously HSE, end users, local fisheries. So there are a few, we'll go into this in a bit more detail in a couple of weeks' time, but there are a huge number of interfaces And if you don't get all of them right, it can slow you down, it could cause problems. Just skipping across to some of the other diagrams that we've got there, some of the other pictures. Those are some examples of buoys that have been used. There are a number of other buoys on the market, but these are some of the buoys that we've been using. As I say, you go from something like the one on the bottom left, which is 2.5 meters across, weighs about 2.5 tons, and then one on the top right is more like 8 tons, and it's towed to site. So these are some of the differences that we're also looking at. When we compare oil and gas type work with offshore wind type work, the buoys are different. They're designed to carry out wind profile measurements, and the system that does that is quite power hungry, so they have to be big because they've got large power supplies in batteries and renewable sources. Some of the things, so I'm just curious, conscious of time, some of the things that we are aware of that have gone wrong, really basic stuff, like you can put a shackle and a chain together, put it in the water, and 6 months later it's dissolved and your mooring's drifting. That's because of dissimilar metal isolation. So you've got one piece of kit that's being used like an anode, basically, and because seawater is conductive, you get an electric circuit set up and your mooring fails. We've had instances where buoys have been run over because the wrong location has been put on the charts. It's been put in the wrong coordinates, or the buoy's been dropped in the wrong place. And certainly this point on instrument sampling and setup. If you're in a location, for instance, where you've got squalls, these are very high frequency events that last for a minute or two, but the wind speed jumps from, say, 4 meters per second to 15 meters per second. If you acquire your data on a 10-minute or a 20-minute or 30-minute basis, you won't see those events. So you can, right at the start, when you're specifying your campaign, you can shoot yourself in the foot later on down the line from a design and an operational point of view, because things like squalls are very important. If you think a wind turbine is rotating in a 4 meter per second wind speed, and then suddenly it sees, within the space of a minute, it sees 3 or 4 times that, it's going to change the loads completely on that turbine structure. Last point, actually, I'll touch on here. Picture in the bottom right is of an autonomous surface vehicle, so an ASV, UUV, lots of different terminology for these things, but we are finding that some of the measurements that we carry out can be done by these systems, and these are becoming more and more, well, we see them everywhere. We see drones used for blade inspections. We see them, autonomous vehicles like ROVs used for subsurface cable inspections and offshore substation inspections. So a lot of things, we talk about safety, a lot of these safety aspects can be removed in terms of operations by using these vessels. You've got a small kit like that, but some of the biggest ones are 15 meters, weigh several tons, and can operate at 4 knots for 50 days continuously, and carry a payload of 7 tons of equipment. So there's a huge potential game change coming in some of the work that we do with these autonomous systems. Yeah, given that we're running on a bit, perhaps we move across to the next slide, Sarah. Yeah, we'll talk to some expert users. Sarah's mentioned that we've got a lot of interfaces in delivery, and I've mentioned that there are probably at least a dozen as we go through that timeline on the right, from installation to decommissioning. But end users have a huge range of knowledge of using Metocean data. And it's pretty key for us to understand how they use that data. So I'd like to introduce, well, first of all, thank you for your time. Introduce Tom and Tony. Tom, Steve and I manager. Has worked in the industry for what, more than a decade, Tom?
15 years.
Yep. Okay. And Tony, marine services manager. Like me, oil and gas background, but marine services very important, obviously, for what we do in running and operating vessels. So, hi, thanks for joining. Good to see you.
Good to be here. Maybe I should just say, Tom, so I've indeed been around 15 years in offshore wind, different developers, from Centrica, which is British gas to those people who live in the UK, to RWE and Shell as well. So, and transport and T&I, for those who don't know, is transport and installation. So that covers the transport and the installation of wind farm components, foundations, substations, cables, or turbines, depending on which one you're looking at. Yeah.
You and I, and us in general, Metocean and T&I speak quite a lot about sequencing, planning, the work that you do, obviously transporting kit around and doing the installation. Can you just give us some examples of where Metocean has helped in that, and maybe some instances of if you've not had the Metocean advice that you need or the Metocean information, how that's impacted what you do?
So a number of things have already been mentioned today. But fundamentally, where it starts at the beginning is with the Metocean data. We really have a proper look at when we could execute construction of a wind farm. So, I think Sarah was mentioned about seasons and different countries being different, and ultimately we need to install components in favourable weather conditions. All of the different lifts and driving activities for foundations or component lifts for turbines, blade lifts, they all have different constraints on wind speed or wave or swell, whatever it might be. And early on, where Metocean and transport and installation work quite closely, is really ultimately determining the seasons which a wind farm could be constructed in, and that's fundamental then to building out how you're going to build a wind farm, in terms of the years that you might be able to get supply chain involved, or whether or not it's a 1 year campaign or a multi-year campaign, with the foundations in 1 year followed by turbines the next. All of that comes ultimately from how much you can do in the weather that you have available. Additionally, John, I think when we start to look at Metocean, it really helps to drive your vessel selection as well. So from my perspective, I'd be looking at which vessels can do the work and can they operate in that region in the right sort of weather conditions that you're expecting to have. So, if you're in a very calm area of the world, then you can probably open up your contracting supply chain to a larger number of vessels, which may not be constrained to higher weather limitations. So these are kind of really live examples of where the Metocean has a direct influence on exactly how you can build a wind farm. And to answer your second question then about the sort of limitations, I suppose the biggest one that we normally have then is indeed the amount of time and the checking of the weather downtime assumptions to kind of then build out the duration that you're going to take to have your wind farm. So without that, you really have to take a lot of assumptions in how long it takes to build a wind farm, and therefore how much it's going to cost to build a wind farm, because typically these sort of vessels are on a day rate basis. So the longer you take, the more expensive your project. Yeah.
So if that uncertainty is biased one way or another, you could gain a lot of money if you do it quicker than you expected, or you could lose a lot of money. Okay. And those decisions that you're talking about when you're doing the execution activities, are you in control of those decisions, or is there because you're using a third party to do the installation, so you could be saying, right, it's fine, we're going ahead? Are there instances where they say, no, we're not?
Yeah, of course. If they ultimately the master of the vessel is in control of everything that's happening offshore, but we will have agreed with the company already that's doing the work to what limitations they should be able to work to, and so therefore, you have to have a really robust way of monitoring offshore. And you've mentioned buoys already. I think Sarah also mentioned buoys in the execution phase. So we would expect typically to have at least 1 or 2 Metocean buoys in the construction phase of the wind farm, which are doing live measurements of sea state. That coupled with a solid, robust forecast, all of which we get from third parties, means that what that means is your Marine Coordination Centre, who are basically the people who are monitoring all of the activities in the construction phase, have a really good view of the conditions that you're expecting on those days and into the future, 5 days into the future, so you can kind of plan your activities and make sure that you're working in the right sort of agreed weather windows. And all of this ultimately allows you to work on a sort of case by case basis. So there's certainly examples, for instance, where the weather forecasting in the Metocean demonstrates that for the next 5 days, for instance, you're not going to be able to work. You can make decisions then about whether or not you bring the vessel back into port to load additional components where the vessel, might be in a more sheltered position and can kind of work. So if you're close to the end of your the number of components you're carrying on board, you can use that to your advantage and say, look, we're not going to be able to work in the field for the next 5 days. Let's go back in and let's load up with additional items. And then when we do hit a weather window, we're ready to go again and be more efficient. So all of that is very helpful. Yes.
That clearly demonstrates how dynamic that relationship is between you and the Metocean team, which is very different from what we do in a design phase, which might take 6 months. You're making day by day decisions. Okay, maybe we follow up on that with Tony and talk a little bit about alpha factors. Is that right, Tony?
That's a bit of that's a fairly tenuous point these days. But just to introduce, I'm Tony. I work at Jura here in sunny Aberdeen. I'm a master mariner. Was at sea when I was a teenager and been pretty much involved with it since 20 years here in Aberdeen. I'm involved in rig moving primarily, vessel assurance and vessel inspections and stuff like that. Key offshore operations, go no go type activities, floating offshore structures, FPSOs, rigs, jackups, things like that. So alpha factors, bone of contention there. Touch the nerve straight away there, John. Well done. Very much.
Maybe I could just explain briefly what they are. Alpha factors are from, well, actually, you probably have a better handle on it because you use it day by day.
Yeah, it's. I'm not entirely clear on the attendees here, but it's an error factor basically that's applied and can make the difference of go or no go when it comes to final execution of an offshore project. It's certainly here in the environment I'm in, it can cause quite a lot of contention and stress as to whether or not we should or should not be going. But I would echo what Tom just said there. Really, at the end of the day, the master's decision is final, and that's respected at all times. So we get a lot of nerds, for want of a better word, telling us to use alpha factors and to the decimal point this and decimal point that. But at the end of the day, observations are important, and that's one of the key points I wanted to highlight here, John, is the value of taking local observations and feeding them back into the duty forecasters day of work, because quite often we'll get forecasts that are wrong, and maybe both or three of them are wrong. But it's really important that the guys on the installation vessels, whether it's wind farms or oil rigs or whatever, are capable and aware of their obligation to feed back local observations to the duty forecasters to help them to tweak whichever model they're using, whether ECMWF or any of the multitude other models, it can help. That can really help defuse tense situations with regards to go no go. That was one of the key points I wanted to. So one of the questions that you said was what type of Metocean support you typically need. That is an example of it. You know, we need to know that the purveyors of that forecast are, you know, got the right guy or girl on the end of the phone 24/7. One observation I have over the years is sometimes you get the day shift and night shift, or a shift A and shift B. 6 o'clock in the morning, the forecast comes in and it's wildly different to what you've been looking at all night long. Yeah, that's something to be aware of when you're talking about Metocean forecasting, quality, consistency, and the ability for the individual forecasters to stick the hand up and say, look, I've changed my mind, I've made a mistake or whatever, because the knock-on effect to that can be quite considerable when we've got multi-million-pound rig move going or trying to go on. We've seen that over the years plenty of times where we've had to stop for no actual good reason. We thought the weather was going to pick up, but it didn't, and it's down to an individual forecaster's interpretation data. So that's always something to watch out for, right, in my mind. Yeah.
Okay. Really good operational insight. Thank you. Thank you both. Sarah, I'll hand back to you.
Okay, allow me to remove your spotlights. Thank you guys very much. All right, so just to close up, just because we're running out of time, and then I'll open it up in case anybody would like to take a moment to ask any questions. I just want to really quickly go over what I was just typing in the chat about this course. Okay, so as I was saying in the chat just now, in case you didn't get a moment to read it because you were listening to the wonderful experts, John and Sarah will be back with a couple of other experts for a full one-day live online course. So you can attend from anywhere in the world. And by having attended this webinar, you are going to be eligible to take advantage of the early bird price. I will send this all in an email. Don't worry, in case you don't get a moment to scan. But the course page and where you can enroll, click this enroll button, is going to be right here on this QR code. And we also have a small FAQ for some more details, normally in case you need to go to your boss to justify why this course would be important for you or your business. That should answer a lot more questions in a much more simplified, smaller format. We also have scholarships available. The same link will be here, or you can send me an email at sarah.colmus@owlacademy.com. We understand that some people are individuals that are not coming through the company, and also that there are countries in the world that don't have as high of a salary and that this kind of price is too much. So we're happy to help you on this, to make this training accessible for you, because we do believe that offshore wind training should be accessible for many people that are interested. So, all right. I will email this out, like I said, but if anyone has any questions, actually now I will just allow you to raise your hand and come off mute. Otherwise, we'll close. So does anyone have any questions for our experts? Does not seem so. Okay, I'm sure everyone's saving them for the course. So great. Thank you so much, everybody, for coming. And thank you so much for our instructors and our experts as well for your knowledge. All right. Have a great weekend, everyone.
Cheers.
Thank you. Bye-bye.
See you.
Bye-bye.